at Kia Motors USA. Henry is going to talk about the fully autonomous vehicle, right? And also a technology for the future, paved with potential and challenges as well. Henry, may I request you?
Hello everyone, and thank you for having me here in the great city of Dubai. Alright, so what we're going to do here today is talk a little bit about the autonomous vehicle and what it presents from a capability, possibility, as well as the challenges. So before we get started though, I'd like to kind of start off with a quote that I really like this quote. It's about essentially the topic that we're talking about here today. It fits very well. The future is already here, it's just not very evenly distributed. This gentleman here, William Gibson, said that, and it's really fitting because, believe it or not, we have the possibilities for an autonomous vehicle already on the road today. A lot of the active safety features that we have in vehicles is the fundamental architecture that will be used in autonomous vehicles in the future, in the near future and the long-term future. So why are we here today? There are certainly reasons why we're talking about this type of possibilities, and a lot of it comes from the disruptions. A lot of disruptions are happening in our world today. The first thing we're going to talk about is essentially the change that we see in the ownership model. So from a move into what we call access, and if you look at Uber, if you look at Airbnb as examples of how that change is happening, you can see that this is one of the disruptions that are going to fit into the talk I'm going to be doing today. The other aspect is this movement from what we call the human to the machine, and essentially that is really powered by what we call artificial intelligence and machine learning and technology. The third disruption is what we call the move from physical to virtual, and you see that everywhere in the world, especially in the era of startups and the new ideas of making our life more convenient, easier, and so forth. So those are really three social disruptions that are happening in our world today in terms of driving into this world of autonomous vehicle. So the disruption also translates into what we call the vehicle space. So the vehicle is basically your second largest investment you make after buying a home, for example. And certainly does find its way always in terms of being in the thick of technology and what's happening. So connectivity is here, mobility services are on the way, urban mobility and e-mobility is something that is certainly at the starting point and is going to take a lot of form real soon. But today the focus of this talk is around autonomy. And all these technologies are finding their way towards the vehicle. So it's really interesting, where the car was just 10 years ago, where it is today, and where it will be 10 years from now. The transformation has taken essentially years into a really fast pace of new things that we're going to see in vehicles compared to, per se, the last 100 years, which really been kind of incremental improvements in the vehicle since the production line started in the early 1900s. So, autonomy defined, basically the National Highway Transportation Safety Administration as well as SAE, the Society of Automotive Engineers, agreed on a standard in which to define autonomy. And autonomy is defined essentially in 5 levels. So the first level is basically what we call level 1, And level 1 is about driver assistance. So if you have one of the features that is similar to what we call adaptive cruise control, that would be considered to be a level 1. And then you start moving into level 2, which is partial automation. And you can see here in this slide, kind of where the breakdown happens between vehicle and driver. Conditional automation, automation, and full automation being level 5. In my opinion, the leap, from at least a level 4 to level 5 is a huge one. It's a big one, and we'll talk about that in a little bit. But in this presentation, I'm going to focus on essentially the full autonomous vehicle, because we think this is essentially we're going to realize the full potential of what it brings to the table in terms of the possibilities, the enablers, and the benefits. These are examples of the levels. So if, again, you go through one by one, you have level 1, which is what we call an active safety feature, things like adaptive cruise control, ACC. Then you have level 2, which is a combination of the two. When you have two of those features coming together, that's considered to be a level 2. And then you get into 3, which is traffic jam pilot, which is essentially you handing the control over to the vehicle, and you can be distracted, in terms of not having to pay too much attention to the road, but you have to intervene in case you are required. Highway driving. So imagine being on the highway and turning the controls over to the vehicle. Imagine like a autonomous vehicle lane is dedicated for vehicles that are autonomous capable, and you can really be more productive and have the vehicle take over and make sure that it's doing what it's supposed to do, taking you to your destination. And the last one is level 5, and this is your automated taxi. And imagine you on a mobile phone app calling the vehicle without a driver to come to you and pick you up, drop you off, what have you. So what are the impacts of an autonomous vehicle? And basically here is very important to note that the impact is going to differ. Essentially, number one driver why we're looking into autonomous vehicles as automakers is really safety. And so if you talk to the government agencies, you talk about why are you essentially on this revolution of autonomous vehicle, the first statement they make is about safety. And it's definitely a responsibility for all of us to make sure that we're saving lives and we are providing safe environments. The second aspect is what we call accessibility. So imagine the possibilities, the opportunities for the people that don't have the ability to drive to be actually dependent on or independent of someone having to drive them, and the vehicle can provide that for them on its own. So imagine from a social perspective the possibilities for those demographics of peoples. The other aspect is obviously very important is traffic. In our cities, it doesn't matter which country, which world we live in, traffic is a big issue that we struggle with. And in terms of more and more cars are going on the road, more and more people are driving, and more traffic is happening. And the limitation is the infrastructure is not that flexible to accommodate just additional vehicles and so forth in a very short period of time. It's costly and so forth. Attached to that is what we call the fuel economy aspect, or in terms of when you have more controlled environments and more of technology that is available to you from an autonomous vehicle, you save on fuel, therefore you save on emissions. So it's all tied together. It's like a nice little puzzle that comes in, and the benefits starts to stack up together as these vehicles take to the road and become more of a mass production. On the last part is really kind of very strategic and long-term, is the civic planning, and in terms of cities, urban environments, highways, the way we handle the accommodation of a autonomous vehicle is very important, and how it affects essentially the cities and their planning, and how we really go about these 10-year, 5-year, 15-year plans to build our environment around us. And the last element here is what we call the macroeconomic issues. And believe it or not, there are definitely a lot of dimensions to the autonomous vehicle in terms of the effect. And we'll go through those in a little bit more detail with examples as I move forward. So immediately, as I mentioned, the full realization of the autonomous vehicle is safety. And this is something that I want to share with you. 30,000 lives are lost to the roads because of crash, because of basically accidents. So imagine what this type of technology can do to, if we can even reduce that by 90%, imagine the number of lives that can be saved. I mentioned accessibility and having mobility for the non-drivers as another dimension from a social perspective that has an immediate effect that can be realized by those folks that need it. There are indirect effects. We talk about mobility. The autonomous vehicles will enable car sharing, ride sharing, and multimodal transport. It will also, from a traffic perspective, it's a very, very key technology in making sure we have increased road capabilities and capacity. We will have technologies like platooning when they come together as vehicles and are more efficient in their transportation, efficient intersection stops and so forth. So these are the type of effects that we realize with the autonomous vehicle as well. We talked about the emission reduction, CO2 emissions, because now less vehicles are traveling the road in a more efficient way. Fuel economy is improving, and therefore you would expect this type of effect to take place as an indirect benefit from the autonomous vehicle as well. And last but not least is really the more of the not a benefit but more of an impact on our system in terms of macroeconomics. So if you imagine if the vehicles become so safe that they don't really collide anymore, or they become so safe that you don't need an insurance adjuster anymore. There are less legal people required, there are less collision shops required. So there is definitely an impact, and these are just examples that just come straight to mind. I'm sure there are much more in terms of what the auto industry and its ecosystem provides from a business perspective, from people's perspective in their lives, how this autonomous vehicle will affect them, just beyond just the technology itself. And then we talk about the civic planning aspect in detail. Things like what do we do with something as simple as revenue generation for cities from traffic violations, fuel tax, and something simple as licensing and parking. So those are things that you have to keep in mind as well, because there's definitely going to be an impact on that front as well. So just putting some numbers around the economic effect of the autonomous vehicle, and this is a research that was done by Morgan Stanley. I mean, the numbers are huge. I cannot vouch for the numbers. I have not done the business case, but I'm assuming the people at Morgan Stanley are very smart in financial aspects, and they predict a $1.3 trillion benefit if you march down the path of the autonomous vehicle in terms of impact. And that is in lives saved, obviously, in fuel saved, in the emissions, and the total ecosystem of the autonomous vehicle is incredible in terms of the opportunity. Now, whether these numbers are correct or not, this is really up for debate, but certainly intuition will tell you that certainly the opportunity is definitely there. So, what is needed to have an autonomous vehicle on the road, basically, to make that dream a reality? There are many aspects, and in terms of what needs to happen, in terms of making this available. Obviously, from a technology perspective, you need a systems architecture that can support this type of technology. Whether the vehicle itself, or whether it's the vehicle around it, in terms of infrastructure, vehicle-to-infrastructure communication, vehicle-to-vehicle communication, network, 5G networks with low latency and so forth. Obviously, safety and security is a big aspect of the autonomous vehicle, because the cybersecurity has taken quite a bit of form in our lives in terms of being a concern and being a worry as part of the automotive space, something we did not really think about too much 5 years ago. in terms of worrying about hacking, worrying about cybersecurity threats happening in the vehicle space. So our world is changing as well in terms of the issues and challenges that have to be overcome. Legislation is a big issue in the U.S. We have essentially like a federal and a state challenge that you have to deal with in terms of making sure everybody is on the same page. To give you an example, on the state level, there are states that are supportive of this technology, and there are some states that are against it, declared that they will not support this type of technology, and there are states that are kind of neutral and sitting on the fence waiting. So the federal government, though, has taken kind of a very good stance in terms of supporting and declaring that this is a must-have technology for the roads. And so essentially they also stated that they will not mandate to the states such technology, they will just recommend. So there's something to deal with here in terms of what's happening in the legislation. And it may not apply to other regions. Maybe there's more essentially capability to apply and mandate, but in the US it's certainly definitely one of the challenges that we have. And obviously also you need very precise map data. Today's GPS is accurate to maybe 2-3 meters, but it has to come really down to centimeters in order for this to really work very well. So it's one thing to note as well from a technology perspective. We do quite a bit of simulation in labs. We use essentially very special GPS when we do these type of prototyping on the autonomous vehicle, but to take it to the full production and have it available for the masses is also a step that needs to be taken. So, one thing I mentioned earlier when I started this presentation is that really there's a lot of this technology, actually the fundamental architecture is already there. And so, believe it or not, the vehicle is a very complex piece of machinery. And if you compare the lines of code in a vehicle today, it has more lines of code than an airliner. It has more lines of code than a lot of the things that you never thought would be as a complex system. So the vehicle has very complex software, the vehicle has very complex hardware, a lot of sensor information, a lot of controllers, a lot of computers are running in the car. So the fundamental architecture in terms of the hardware and software is already here. And in terms of where we are today, obviously active safety features are essentially finding their way not just on the premium segment, but also on the mid and low tier segment. Autonomous electronic braking will be available 90% by 2023 in the US in all vehicles. This is A segment, B segment, C segment, it doesn't matter. So active safety is the fundamental architecture, and autonomous vehicle is the step above that, which is, he's talking about sensor fusion. You're talking about taking the existing architecture to the next level in order to realize some of these capabilities for the autonomous vehicle. Here's a summary or a slide about some of the technology fundamentals. This is a Kia Soul EV. And between the LiDAR, radar, and sensory information, this is what the vehicle sees. So this is a picture of what the vehicle sees in terms of handling the autonomous road, autonomous dream in terms of having the road while driving in an autonomous mode. So when do we see this? So there's been a lot of declaration on when we will see the autonomous vehicle. We're talking about 2020 as having highly autonomous, and then 2030 is your full autonomous dream. I mean, obviously, when it comes to the technology, can you actually predict 5 or 10, 15 years out? I argue we cannot, but certainly the industry has used these type of dates as the target to establish this type of technology on the road. So we'll see. This is kind of a roadmap on where we see when, and in terms of full automation, non-automation, and conditional automation. Obviously, the highway presents a very attractive place for an autonomous vehicle because it's a limited access road versus an urban environment. It's a highly complex road, right? If you're in a city in an urban environment, you have to deal with pedestrians, cyclists, pets, people, all kinds of complexities. That is a far more complex system and surrounding to really handle versus a highway, for example, that has an autonomous lane, for example. So we need to talk about the barriers. So I mentioned, at least in the US, the social barriers in terms of handing the keys over to a robot. I mean, there's a psychological mountain to overcome here because people may be very hesitant to do that. Some people say, you know, I want to share the road with an autonomous vehicle, and some people say, you know, I'm not willing to do that. So these are kind of generational things and social things that it's hard to manage, but certainly exists in a certain way. This is a study that was done recently, maybe about less than 1 year ago, and it talks about from a acceptability perspective, people's willingness to accept such technology. And I thought it was fitting because in the UAE, for example, is one of the regions in the world that actually are very open to this type of technology. So I thought it was very interesting to put that in here in terms of showing to the crowd here. So you can see from a global perspective, almost 60% of people are somewhat accepting of trying the technology, but certainly there are people, certainly are very hesitant to accept it. So even from a global perspective, there's a lot of difference of how people perceive this technology and their willingness to accept it. I mentioned cybersecurity. The prospect of cars that can drive themselves also open themselves up for security concerns. What if a hacker takes over that vehicle since the driver is not there? What would they do with that vehicle? Right? If the vehicle is in a full autonomous mode and is being hacked into, that makes it a very dangerous weapon. Right? You're talking about 4,000 pounds of steel, and that is something to really be concerned about. And so I'm going to pose that as a serious issue that will always be a moving target, as in the IT world, we deal with the same situation. The ethics barrier, and I mentioned earlier some examples of that, jobs being not available anymore, made obsolete. From a social perspective, this is a very high agenda item that, from a political perspective, from a corporate citizenship perspective, you have to also take into account in terms of the effect of the autonomous vehicle from a technology perspective. Liability is a big issue in the US in terms of litigation. We are a very litigious society. So we have to worry about who's at fault at all times. And really this is one of the open issues. It's not a technical issue, it's a legal issue, but has not really had a whole lot of attention in terms of how do we fix this, right? In case of an accident between an autonomous vehicle and non-autonomous vehicle. So who's at fault? Can people sue, the company? Can they sue each other? So this is really another, basically non-technical issue that has to be resolved. I mentioned legislation, and a lot of it is essentially on the federal and state level in the U.S. Regionally, it may differ. Again, maybe in China or other countries, it may be easier to mandate or make this technology available because they don't have to deal as much of scrutiny on the legislation side. There's also economic barriers. We're talking about technology that costs money, and in terms of the phases of technology, anywhere between $1,500 to $4,000 can be added to the cost of the vehicle. So when we're talking about adding this type of cost to the production of the vehicle, that will pass on to our customers and make the vehicles more expensive. So there's also an economic issue with that. According to J.D. Power, they did a survey and they asked people and they said, okay, yeah, we're interested in autonomous vehicles, but when you tell them it'll cost you more, people change their mind. So there's a little bit of that we have to consider as well. There's also the technology barriers. As I mentioned earlier, the fundamental architecture is already here, but it's almost like a perfect environment. How can you take into account the corner cases and the use cases that are essentially limitless of what could happen on a road, right? And that's kind of the other leap that has to occur for the fully autonomous vehicle is identifying the most number of corner cases and use cases in order to make sure that the vehicle actually can drive itself on its own without the intervention of the human being. Infrastructure, obviously a huge impact, the roads and signage and all types of communication that has to happen around the vehicle is something to also take into account, but I don't think it's a critical issue, but certainly is something to be concerned about. So in conclusion, autonomous vehicles seems like a distant possibility, but really the technology is rapidly developing. And we have vehicles on the road today in a controlled environment that can drive themselves. And all we need to do is perfect that technology even more in order to see those vehicles on public roads. There's definitely an economic benefit and a social benefit that has to be quantified. There are definitely barriers that have to be overcome. And the framework for the liability aspect is a major concern in the US. And the policy making is the largest effect, in my mind, on the future of this type of technology. The involvement and the direct involvement of government is very critical to make sure that we get there. And this is my last slide, and for those doubters out there, and I know not in this room, but in the world, really you just gotta take a look at this slide. It's self-speaking, basically. So we have to change our thinking from traditional to open-mindedness. And that is my presentation.